fellow judges, I am Raquel, captain of Team 109 Crow Force from Sage Creek High School. We are so excited to share our hardware, software, and business innovations with you this season. To incorporate our goals effectively, we have implemented project management using agile methodology, dividing our work into 2-week sprints, which ensures every member consistently has a task to work on and has increased our organization and time management overall.
This year, we succeeded in building a robot that can pick up and place pixels from anywhere on the field, navigate the trucks effectively, launch an accurate drone, and hang. Our main goals were to learn from the successes and failures of last season, as well as to prioritize efficiency in our design system.
Before building our robot, we designed it all in the CAD software Fusion 360. We focused on a modular system this year, starting with the chassis, then the arm, then the intake, ensuring that each module worked independently and functioned together cohesively.
A struggle last season was our intake and outtake system, since both were on the same side. This forced us to rotate during matches and cost us valuable time. Now our intake and outtake system extends through the entire robot from end to end. We intake pixels using our rear intake, and then we intake them through a ramp through a series of boot wheels into the bed where they can be grabbed and sorted by the claw.
Specifically, the first pixel we intake through the intake will always go in the right position, and the second one will always go on the left, and this gives our drivers and our coaches a lot of control over pixel placement on the board.
Last year we had problems with linear slides, so this season we opted for a triple jointed arm. This increases our range of motion, skipping pixels off the ground, our speed, quickly placing them on the backboard, and our strength, hanging using this bracket.
One challenge we had this year were constant IMU tests due to static discharge. We consulted Mr. James Abernathy, who works at Nordson, and we came up with 2 solutions. One being an electric grounding strap which grounds our electronics to the frame, and the second being a sensor assembly to give redundant sensor data. We also open sourced this project for other teams to use.
Since half our hardware team is graduating this year, we decided to give younger members more responsibility. We improved our skills by CADing and designing the intake, the drone launcher, and the mechanical arm.
This year, software was able to deliver a strong and sensor-focused autonomous by Competition 1, as well as build code that allows the drivers to focus on navigating the field rather than precision elements to the use of automation. Our autonomous begins in initialization, where the driver can select alliance color, pixel placement height, parking location, and a delay to avoid interfering with alliance partners.
Then we used machine learning by training a model for detecting our game element. To help with our efforts, we met with Samuel Hunter, who has a master's degree in machine learning from Stanford. He helped us understand how TensorFlow works and how to interpret data to optimize our game element for more accurate results. We also got a head start on the framework and structure of our software solutions by using last year's robot from the start of the season while the hardware team was building the robot.
We created 2 different classes, April tag alignment and arm control, which could go aligned to any of the 3 different April tags on the board from up to 2 meters away using the distance sensor, IMU, encoders, and the camera. We also coded the 3-pronged arm to reach any position on the board, and we were able to make the claw drop 2 pixels simultaneously. Being able to quickly align to any spot on the board while also being able to have no room for human error allowed us to distinguish ourselves as a quick and precise mosaic builder. As a testament to our accuracy of these modules, we had 6 perfect 50-point autos by Tournament 2.
In teleop, the second driver can pre-select the positions of pixels, but the first driver can collect and navigate the field. Drivers can then accurately place pixels without a single button, which uses state machines that allow multiple substates to run simultaneously, including our alignment and arm control classes. We also implemented LEDs this year that allow the robot to better communicate to the driver about what it detects.
We are so excited about the impact we have made this season through our outreach events. We began local with events within our school, including Club Rush, a school-run carnival, and an outreach event put on by Sage for incoming 9th graders and their families. By mentoring and recruiting last season, we have been able to grow the robotics program to approximately 100 members. This has resulted in the formation of a brand new team, Team 23997 Catalyst. This being their first season of FTC, we've been able to guide them through their first year, teaching them new skills both soft and technical. This also helps to ensure the sustainability of the robotics program at Sage, as well as our team for many years to come.
We have furthered this impact through various outreach and fundraising efforts. We demonstrated our robot at our first at a career technical education showcase, an event put on by our school to introduce 8th graders to high school programs, and we also mentor local FLL teams and volunteer to judge at local FLL events. We host and run many fundraisers with many local companies, including Inglorious Bagels, Icetown Ice Skating, and the French Corner Bakery.
We reached out to companies such as Nordson, Rockstar, UCSD, and Thermo Fisher through discussions and internships, which helped us gain knowledge that we could bring back to our team. We are also very happy to have worked with the robotics team Horcrux from India, who will be representing their country in Houston, Texas at the first championship this year. We plan to continue expanding this impact through other future outreach events.
This year, we have drawn from past experiences and used continual learning to create, construct, and program an aesthetic and functional robot. We have had so much fun sharing this robot with our community and sharing our love of FIRST. Thank you for listening, judges.